Hey everyone, welcome to Gotta Catch 'em Algorithms, a YouTube video series where we're going to be using Pokemon to solve data structures and algorithms for LeetCode questions. In this video, we're going to be going over LeetCode question 704 binary search. Now, I love this algorithm for two reasons. One, it's a very powerful and popular algorithm that you're probably going to be using a lot if you continue working with LeetCode. And two, it's a really great introduction to a time complexity called O log n. Now, if you're not familiar with the algorithm or the time complexity that I just talked about, stick around and I'm going to be sure to explain both. So before we jump into the code or even the algorithm, let's make sure we understand the problem that we're trying to solve. So in this example, we're given an array of ascending order, meaning all the numbers from left to right are constantly getting larger with no repeats. And here in the index of 4, we have value 9 where Charmander is hanging out. And we need to find Charmander with a time complexity called O log n. Now, if you're not familiar with binary search or even the time complexity in general, you're probably looking at this problem and thinking, oh, well, this is actually really easy. This is basically just an array, so I just need to check every single index one at a time going across until I find Charmander. So if you use that strategy, let's see what happens. Okay, so unfortunately, that wasn't fast enough. Charmander ended up getting the upper hand on Pikachu, and now Pikachu is on fire, the array is on fire, even I'm on fire. So we need to figure out a way to come up with a faster solution than just checking every single index one at a time. In this slide, we're going to go over a quick introduction to something called time complexity. Now, you might be looking at this chart and thinking, well, this seems a little bit really intimidating. You got all these like symbols, maybe some complicated math. No, it's actually really more simple than that. So the O in all of these symbols represents order of. So basically saying, how long did it take to do something? And then whatever the symbol is inside the parentheses next to the O represents the length or amount of time it took to do that thing. So to explain O of n, in the previous example, we had Pikachu check every single index one at a time to try to find Charmander. Well, that represents O of n because he had to do something with the entire length of the input array, which is represented by the letter n. So if you're ever writing code and you make a for loop or a while loop or whatever that's iterating through every single index in an array, you are doing O of n time. So as you saw from the previous example, that wasn't fast enough, so we're going to be using something called O log n. And one of the best examples I've ever heard to explain how O log n works, I want you to imagine if you had a phone book and you were looking for the letter C as you were looking for Charmander. Well, you'd probably open up that phone book and split it right in the middle, and you'd probably land on the letter M. Now you'd think, okay, the letter C is less than in the letter M, so you would just take that left half, splice it down the middle, probably wouldn't find C, so you'd probably have to slice it again and again until you get to the letter C. That is basically how O log n time complexity works. And in the next slides, we're going to go over the algorithm before we jump into the code. All right, let's learn binary search. So we're using the previous array that we had at the beginning of the video, and our target value is 9, where Charmander is out hanging out. So to get this started, we need to make some variables. The first variable you'll need is a left variable, which will be set to the beginning of the array. The next variable will be a right variable, which you'll need to set to the end of the array. And our third variable will be a variable that'll be set to the middle, and you will decide what the middle is by taking left plus right, dividing it by 2, and then rounding it out using the JavaScript built-in functionality math.floor. So 0 plus 5 divided by 2 will return you 2. Now, one of three things is going to happen with the mid value. One, we're going to check the array with the mid value and determine if that index is equal to the target. If it is less than the target value, then that means we need to take the left pointer and move it one space to the right of mid. Or it's going to be the opposite, where it is greater than target. In that case, we need to take the right pointer and move it one space to the left of middle. And then we need to reevaluate what mid needs to be using the two updated pointer values. So I have our three checks here that we're going to need. We have if array mid is target, array mid is greater than target, or if array mid is less than target. Let's use these 3 checks to see if we can find Charmander. So the first check, is array of index 2 target? Well, no, index 2 is 3, which is not 9, so that won't work. We have if array of index 2 is greater than target, so 3 is not greater than 9, so naturally we're just going to go to the third one and check if array of index 2 is less than target. Yes, 3 is less than 9, so we need to set the left pointer to mid plus 1. That will move that there. So now what we need to do is we need to update our mid value. So that will take these 2 variables, which is 3 plus 5. It will divide it by 2, and it will round it out using the math.floor functionality, and it will make it equal to 4. So now that we've gone and updated mid, let's go ahead and go through these 3 steps to see what we can find. Here, we're going to check if array of index 4 is equal to the target. And as you can see here, yes, the array of index 4 is equal to the target, so all we have to do is just return this index. And just like that, we are done. We have found Charmander using a O of log n time complexity with binary search. So now that you understand how this algorithm works, let's go ahead and jump into the code. So to start off with binary search, we need to create 2 variables. First, we need to create the let variable and make it equal to 0. Next, we need a variable that's going to check the very end of the array, so we need to make a right variable and make it equals to nums length minus 1. We're going to need a continuous while loop that will check if left is less than or equal to right. And remember that important mid variable that we needed to check to see if we need to go left or right? Well, let's go ahead and create that at the very top of this while loop. Create let mid equals math.floor, set it to left plus right, divided by 2. Now it's time for our 3 checks. Make an if statement that will check if nums mid is equal to target. If it is, then just return the mid value, which is the index that we're looking for. We'll need to do our second check, so make an else if statement that checks if nums mid is greater than target. And inside that else if statement, make sure you set the right variable to mid minus 1. And with the last check, we just need an else statement that will turn left into mid plus 1. The last thing we need to do is make a return value outside of the while loop. Now, if we go through the entire array using the binary search method and we can't find the target, then that just means we need to return minus 1. Let's submit it. And the question got accepted. And that was LeetCode question 704, binary search. If you like this video, please consider liking and subscribing. I plan on making more videos in this series to explain other sorts of algorithms and data structures. Also, if you have a favorite Pokemon, please put it in the comment section, and that Pokemon might appear in my upcoming videos. Other than that, I am Jamie Dawson Codes, and thank you for watching.